Hello everyone, I'm Utkarsh and I'm an AI engineer and my focus is on agentic AI orchestration and building backend pipelines. For today's walkthrough, I wanted to show an architecture that solves a very real business problem which I have dealt at my previous company. Our clients were mostly from the BFSI domains, that is the banking and financial domains, and we used to make CRM software for them, and my role was on the MLOps side. Like we had a massive unstructured support queues, and the customer service team was spending hours to manually reading tickets and referencing the compliance policies and querying the databases and then routing the tasks. So it was a tedious task, so I had given them a solution, and for now I tried to simulate the similar workflow and here at n8n in this demonstration. So I took that experience and built an automated counterpart, and it uses a LangChain agent connected to a RAG agent pipeline and a SQL database to ingest tickets. And to read after reading the standard operation procedures and then making policy decisions and execute multi-channel actions using the RAG. So let me walk you through the infrastructure. So at first, let me show you the ingestion pipeline. So let me first run it. To start with the underlying infrastructure, I deployed this n8n instance via Docker alongside with the local containers for Postgres and Redis. I prefer managing my own containerized deployments for workflows like this because it gives me a better control over my environment and also the network isolation thing. So for the ingestion pipeline, before the agent can do its job, it's need the ground truth data. Like if we have this banking issue, there are particular banks, they have their own set of rules that needs to be followed. So down here, my ingestion engines, it take our internal banking standard procedures called SOPs. Let me show you that. So this is what I have added here. It's a set of instructions. So it dictates the fraud prevention rules and the fee structures, and then we pass them through the Google Gemini's embedding models, and these models are up inserted into the quadrant vector database, which is known for its low latency, retrieval latency. So now let's go to the main pipeline. So this is the ingestion part, which I already explained to you. And this is the main pipeline, which the main problem is being solved here. So let me give you a brief about what is happening first. So let's say that when we go to a bank to get a new credit card or something, so we we have different criterias for that. Like somebody have opted for the standard option, or somebody had opted for the premium option, and somebody have the VIP options. All three services are different and they have their own pros and cons. So here in this scenario, we have three tracks. As you can see, we have standard track, premium track, and VIP track. So in general, in the standard track, a normal procedure will be done. Like it's the slowest track. Like in general, you if somebody lost a card, for an example, a Jira ticket will be issued, and then after a while a human in the loop will take care of it whenever he or she will get time and according to their queue. The second track is the premium track. Here we give some benefits to the users, like they will get the card delivered for them free one time in a year. And for the VIP track, if something happens, then a direct instant Slack message will be gone to the employer, and they will immediately will be assisting the VIP user. So this is the simple approach that is happening here. But how I am implementing it, that's an interesting approach. So we have a multi-model ingress here. As you can see, we have the Gmail trigger and the webhook trigger. So uh, we handle model request via the authenticated REST pipeline. And you can see there the webhook here. Let me show you. And we have this authentication too for the security purposes. And we also support the Gmail trigger. So let me start with the Gmail trigger and let me run through a example of it. Okay, so let me run an example of the legacy flow, and I'm going to simulate a customer sending a standard support email. So compose. All right, let's send it and see this workflow. Okay, so as this was a example of a standard track, to see how it worked. So initially the Gmail trigger got activated, and the first thing you'll see is that it hits a Redis rate limiter, and because the LLM APIs cost money, so it runs an incremental operation against the sender identifier to protect against spam or infinite loops. Then it hit the Node.js normalization script, and since an email payload looks totally different from the and webhook payload, so the script normalizes the data into a standard JSON schema and then dynamically generates a ticket ID if there is if it is missing there. So the next part is you can see that it will go to the agent, which I'm going to explain you later. And then according to the switch, it went to the Jira ticket, and a ticket is created here. Let's see, ticket has been created here, and then created a draft. We can check the draft here. It's the latest one. Oh, the same ID. So this one is for the standard track using the Gmail. And now let's go towards the AI agent part and the rack execution part. So to explain this, I better use the webhook approach first, and then I'll explain you how it works. So I had my payload ready. So first we need to change it from the Gmail to the webhook part. And let me show you, I have some of the payloads ready. Here I implemented it through the Docker, and then I have my SQL setup. I have my payloads for the premium and the VIP members. So let's try the premium one first. All right, so let me execute it here. Since it is executing, let's and the workflow is started. Okay. So what happened here is like this is for the premium one. In the premium one, the workflows goes like it first goes to the Redis for the rate limiter part, and then the normalization part. It's check the formatting and make it normalized stuff, and then the AI agent part. So as we can see in the RAG ingestion pipeline, we already have like the banking SOPs, and then we have our vector database, and the document and the embeddings are being stored in that vector database here. And then we use that here. Like just let's look at the webhook ingress, right? It's coming it like that. And one more thing is the authentication part I have also added, so that for the security purposes there is some authentication here, and that's the reason I'm passing that authentication token here too. Yeah. So as we look at the webhook ingress, it's a much more complex request. So when the webhook receive this is passed as the normalization to our LangChain agent and powered by the Gemini. But the agent does not guess the policy. Dynamically call the quadrant vector store tool. It searches the database, find the specific SOP regarding the temporary addresses, which requires extracting the hotel name, number, checkout date, fraud compliance, or any details, and then verifies the customer provided that that in the payload and the structure of the JSON response. And based on that JSON, we hit the switch node. And because if it this is, in this case is a premium customer, uh, yeah, it's a premium customer, then the agent routed them to the middle track. And but we still have some business logic to enforce. That's why I implemented the Postgres here. So in this situation, what was happening is like the premium user only get one waived shipping fee for a year, right? So the workflow makes a live SQL query to the Postgres database to fetch the user's history, and if it hits an if statement, and if they have zero waivers used, it auto approves it, and if they have used their waivers, then it dropped a payment required email, and it hits the REST API to generate a FedEx label, and then it uses the Twilio to text the customer a confirmation. So you can see Postgre here, show you. I pinned it for testing purposes, and this is it. And then it checks that if it is 0 1. So let me explain you the logic here, my bad. So in the query, you see that the waiver count, we check the waiver count using the customer ID and see that if the fee waived being false or not. Like if it is already being waived or not. If it is already being waived, then we have to take money from them. We have to charge them. Else we can give him one free waiver. And and according to that condition, the waiver is being applied or not, it will go to the either auto approve, or else the payment required draft, and then it go to the generate shopping, and the to SMS will be there. So let me show you any of one of them. So it's like premium alert, your replacement card has been shipped via priority overnight, because it was from the approved auto approved one. Else it should have come from this one. Then that's the reason I have to show it. I have pinned it. So let's change it and make it one. Save. Let's execute the same workflow. Yeah, now the payment required draft through. Let's see what's the email is now. Yeah, you received your your replacement request. Like you already have utilized your free annual replacement. To expire your new card, please pay the standard fees. And then similarly, this is being configured and then sent to the Twilio to send the SMS. And then finally the VIP track. So to show this condition, let me change the payload. And let's start running it again. Great. So it worked in a way that after the switch condition, it went to the Slack. And let's check the Slack. I already kind of implemented it here. And yeah, see that is 6:01 a.m. My card was shouldered by the ATM device according to the payload which we have sent. It is it came here. And then so yeah, it's you can see that the VIP process was very fast and direct message to the employee through the Slack. So it's for the VIP webhook. So we can notice that how fast this process was. The LLM understands the VIP context and the high urgency from the prompt. It hits the switch node and immediately bypasses all the standard database checks, and it fires a Slack alert directly to the priority team and the logs the event in the. And yeah, for the logging part, yeah. So what we can see that we have the three cases, and after processing to the all three, like first is the Slack one for the VIP, Twilio is for the premium track, and a general Jira ticket and email for the standard track. It is all the three are getting being logged at this Google Sheet, which I have already been okay. So open your yeah. So as we can see, we have the three conditions as I showed you, like the standard, the two premium, the if else statement for the yes and no one, and the VIP one. So all the logs are being maintained here. So this was the general pipeline for that. And yeah, and for the cases where let's say that our downstream is unreachable and the workflows hits the fatal error and it's not working. So what I did is like I also handled this error case by making a global error handler. It immediately like serializes the node state and the payload and fire it off to our DevOps stack, and also and yeah, and then it also like send a message on the Slack. So let me show you that. So whatever, it's a global error handler. So whatever the issue is happening, it will directly sending the trigger here and show you how it creates the trigger. So in the error log, we can see that at 6:04 this failure comes and how it is being connected to that. So it's a global system error handler, and we can connect it through displays and the settings. We just have to select the global system handler, and whenever there is an error, it will directly gives us a Slack message for that. So this is the architecture. So we covered the REST webhooks, structured LLM generation, vector search, SQL integration, and the observability. What I love about this space is that how fast it's moving, and whether it's like Gemini's or a new Anthropic model integrating the MCP to let desktop agent trigger these workflows or writing the custom Node.js wrappers. I generally enjoy building these robust automation systems. And I hope you like my workflow, and thank you for providing me this opportunity. Bye bye.